Cheers and welcome to Irondale Brewing, complete with my whole head this time. I'm not going to chop it off like I did in the last video. Sorry about that, figuring this out as I go. So thanks for bearing with me. Today's topic is cold crashing, why you want to do it, what some of the options are, and the challenges I ran into with this Fermonster setup. So cold crashing, the concept is you basically take your fermented beer once it's done and you crash it to a cold temperature, as the name implies. So, for example, if you're using a fermentation chamber and you're going to leave it in there and you don't have a need to stick another beer in there at a different temperature, you can just dial the temperature down to near freezing. I think most people probably just use a refrigerator, so it's 36, 38 degrees, something like that. Leave it there for 2 or 3 days. And what that does is all the proteins and yeast and whatnot that it's still kind of in suspension in your beer, it all floats to the bottom and gets packed in a nice layer of trub at the bottom of your fermenter, keeping your beer cleaner for transfer to packaging, keg, bottling, whatever. The challenges you may run into is a little bit discussion of pressure here, but basically normal fermentation, you probably have a lid like this, and it has an airlock on the top filled with sanitizer. And as fermentation happens, you get positive pressure from the CO2 generated. That's what causes the bubbles. Airlock, as the name implies, keeps air from getting in, so everything's going out during fermentation. The problem with this setup with cold crashing is when you chill the beer, the pressure inside the fermenter is going to drop, and then what happens is sanitizer and air can get sucked back in through the airlock into your beer. You want to avoid that as much as possible. Sanitizer is not going to hurt anything really for the minor amount that we get in there, but hey, you don't want it in your beer probably. But the bigger concern is the oxygen that gets in there, because you've got that nice layer of CO2 after fermentation. And if you lose that and get oxygen in your beer, at that point, you're starting the beer staling process, basically. And certain styles like New England IPAs, higher hopped beers, anything with kind of more subtle flavors, you're going to lose that stuff almost out of the gate if you don't keep it keep the oxidation as low as you can, down to zero if possible. So that's the problem with this setup. A couple other solutions people use. Some people, you can time the attachment of a Mylar balloon to your fermenter. You have to kind of wait until a few days into primary fermentation. You don't want to do it too early. But then at that point, you can put a Mylar balloon on your setup, and it will capture the CO2 that's coming out and keep it in there. Or you can just fill a Mylar balloon with CO2 from a tank or whatever. And then when you cold crash, you can just put that balloon on there, and as the pressure drops, it'll pull CO2 from the balloon into your fermenter. The only question I would have with that, and I've never tried it, is in a fermenter like this, I don't know that the balloon is going to keep the fermenter from getting sucked in a little bit too much, because it seems like there would not be a whole lot of pressure there to counteract the positive pressure coming in to counteract the pressure drop inside the fermenter. But don't know, never tried it. I could be off base there. Another option is something called a cold crash guardian, and there's several DIY solutions, but basically that's a kind of more traditional blow-off tube setup, but it's got 2 jars. I'll put a link. I'm not going to explain the whole process here, but put 2 jars of sanitizer with a tube between them and a bag that's attached, and same concept. It captures the CO2 that's generated during fermentation. Drop the temperature, that CO2 gets, prevents the oxidation from happening, because CO2 is getting sucked back in instead of oxygen. So the challenge that I had with this setup, the idea here is I wanted a closed process to, again, eliminate oxidation as much as possible. So the idea with this setup is gas post on a Fermonster. It's closed, and once you start fermentation, you never open it again. And then I had a blow-off tube during fermentation. But then when you start thinking about cold crashing, this is sealed. And of course, as the pressure drops, the sides of this are going to get sucked in. And, is that going to damage your fermenter? Probably. Again, want to avoid that if possible. So what I decided to try for the first time is just to put a small amount of pressure. These are rated up to 5 PSI, so not a ton. You can't pressure ferment in this really, but they can handle a little bit of pressure. So the concept here is put about a pound of pressure, positive pressure, through the gas post. Again, still closed, got all the CO2 in here. I'm only putting CO2 in, but that will keep the fermenter from getting sucked in and avoid oxidation. How I accomplish that is one of these bad boys. It's a Kegland mini regulator. This comes with a stock 30 psi analog dial. Hard to read, hard to dial into a very precise temperature. So I did replace that with a digital gauge. And then you can really dial it in down to, tenths, tenths of a psi. So that was super helpful. And then the other thing I should talk about is the SodaStream canister. By default, these come with an attachment on the bottom that handles these 16-gram CO2 cartridges. If you remove this, then the threads are the right size for the SodaStream canister. So then you can use these. Obviously, this is more handy, lasts longer, don't have to worry about going through tons of these things. So that's kind of handy. And then the other thing I did is so it also comes with this little barb, and you'll see all this stuff closer up in the next couple of segments, that is duo-tight fitting. So you can unscrew this MFL thread, stick this duo-tight fitting in there, and then, if I can get this right, so you can see it sticking out. And then that is a 6.5 millimeter duo-tight, and then I just use an expander to get it out to 8 millimeters. Then you got a hose into a quick disconnect that goes on top of the fermenter, crank it up to about 1 psi, and problem solved in theory. The other nice thing I'll say about this regulator is it has a separate piercer / plunger for the gas, and then the pressure dial is here. Benefit there is when you put it on top of here, if this is screwed all the way out, you're not going to lose any gas just attaching this to your regulator. The other mini regulators I have, the second you screw one of these things in, it gets pierced, and then you start losing gas, so you have to keep screwing that in pretty quickly to not lose a bunch of gas. So you get it screwed in all the way and then pierce it, or plunge it in this case, and then dial in your pressure there. Also a nice pressure release valve. I don't remember what green means. I don't remember, 60 psi or something like that, where it'll release, so you're kind of safe there too. And then if you can get a different screw fitting on the bottom for these larger 74 gram CO2 cartridges as well. So very versatile, really well made, solid. The other thing is you can swap the connector from the side to the bottom here. You just take this little plate out and swap that stuff out. So you have a lot of options in terms of how to configure stuff. And if you're attaching this to like a normal keg for taking to a party or something, you can just stick a gas disconnect right in it and hang it from the keg. In this case, I did the jumper option because, of course, if you hung this from this plastic thing, it would start to bend the plastic, which isn't ideal. So anyway, that's the approach I took to cold crashing. I want to talk a little bit about the concepts and some of the ways to solve some of the challenges, and I'll show you details at a more close-up fashion and doing it to the actual beer in question here in the next couple of segments. Okay, so to go over the various components involved with this approach of cold crashing, which again is a test for me, never done it before, but in theory it should be okay. Basically, as I said, normally you would have a lid like this with an airlock. And the issue with that is the sanitizer, when the pressure in the fermenter drops as you're cold crashing, sanitizer and air can get pulled back in. And what we're trying to do with this setup is avoid any oxidation at all, which is a good thing to do in general. Some styles are more sensitive to oxidation than others. And for this particular one, the green tea is a pretty subtle thing. So I kind of want to retain as much aroma and flavor as I can and not have it be affected by oxidation. But again, all beers can benefit from this. If you do a porter or something like that, you probably aren't going to be as sensitive to oxidation as with other styles. But so that's the challenge with this. And the problem with a closed fermentation process like this is that to cold crash, you would get sucked back. And if there's no pressure that can go back into it, then the fermenter is going to collapse because it's plastic. If you ferment in a keg, again, probably don't need to worry about it. Well, I can't imagine the keg would collapse. I don't know. It'd probably be fine. But with this setup, I need to do something to counteract the negative pressure that's going to be happening as the liquid cools. So my concept here is that I'm going to use one of these SodaStream canisters with a Kegland mini regulator and put just a little bit of positive pressure. Again, these are rated for 5 psi is also not a lot. I'm going to put like 1 pound on it to counteract the pressure drop within the fermenter as I cold crash. So what you need to do for this kind of setup is Kegland mini regulator. These are really slick. I was using these on my mini kegs before. This will be the first time I've swapped out the gauge it comes with. And in fact, I think this is a different gauge that comes with. It comes with one like this, but that is 30 psi for the scale. So as you can imagine, it's kind of hard to read. This one is 15. It's a little bit easier, but again, for very small increments like 1, I wanted to be as accurate as possible. So the nice thing about these regulators is you just take those 2 screws out and stick different gauges in, which is pretty slick. And then the other, it's not really a modification. It comes with all the parts. It ships with this part, which is just a threaded, the typical threaded size for quick disconnects. But it comes with a barb. Let's see if I can get this off of there. Of course, I probably won't be able to. It comes with a barb that you replace by just taking that screw out and sticking it in there. That is for duotite fittings. And then you need this reducer, which is 6.5 millimeter to 8 millimeter. Put that on there. And then I haven't cut this yet, but get some Evabaria duotite tubing. And then you stick that, one end of the tube into here, other end into one of these duotite quick disconnects. That goes on the gas post, put 1 pound of pressure on it, and you're good. As far as how you connect the soda stream canister, basically the regulator ships with a screw like this that's in the bottom. And the size that is for let me see if I can find one. Yes, happen to have one laying around. These little, I think they're 16 gram CO2 canisters. So that would screw into there. This one does not work with the larger 74 gram canisters, but they do make a fitting for that. But if you remove that from the bottom here, then the threads are then the right size for the SodaStream canister. So you can screw that on there. And if you're doing things with a SodaStream canister and one of these regulators on a keg, you can probably get away with just having a quick disconnect directly into this fitting, the threaded fitting. The problem with this, of course, is this is shorter, and I didn't want to put like a whole bunch of pressure on the plastic. So that's why the plastic fermenters, that's why I needed to do some sort of setup like this. So that there's a hose going. That way this thing can stand on its own. That thing can stand on its own. And I'm not going to mess anything up. So that's all the parts with obviously stuff with no beer in it. And next I will hook this all up to the actual beer and do the cold crash. Okay, so I got the beer out of the fermentation chamber. I've got my little bits in Star San. Been sitting there for a few minutes. Another quick tip. Star San doesn't work instantly. So if you see people spraying stuff and immediately using it, not probably, you got to wait a couple minutes for that stuff to take effect. So I'm going to put all this stuff together and put a little pressure on this bad boy. The beer is looking good. I mean, it will clear up, obviously, as we cold crash, and when it goes in the keg, it'll finish up. But it's been fermenting for 14 days. Tea's been in there for 7. See it floating at the top there, maybe. I don't know. And then I'll probably cold crash for maybe 3 days, 2-3, and then put it in the keg and probably give it a try in about a week. So let's see how that goes. Never done this before. So step 1 is put the reducer, and again, this is a 6 point, well, if you go that direction, it's an enlarger, but 6.5 inch to 8 inch duotite fitting that goes on this barb there. So and basically with duotite stuff, just jam it in there till you hear it click twice. And then what I always do is make sure I can't pull it back off. So, you don't have to really be too brutal with it, but make sure it's in there enough that you can't pull it back off. To get it back off, you push that little thing there in case you haven't used duotite stuff before. Okay, so that should be good. And then I cut about a 6-inch piece of 5 millimeter inner diameter and 8 millimeter outer diameter Eva barrier hose, which works with the duotite stuff. So this is the 8 millimeter side. Jam that in there. Same thing, just hear it click a couple times and then shouldn't be able to pull it back out. And then the quick disconnect that is obviously 8 millimeter. These come in different sizes too, so just make sure I don't think the size matters particularly, but just make sure you have all the right sizes to do this stuff. So same thing there, just jam that on there, get better angle here. All right, that feels pretty tight. Okay, get this bowl out of the way. And if you watch the other video, obviously while this was fermenting, I just had a quick disconnect going into or with a blow-off tube going into a little mason jar of star sand. Okay, so let's see how this goes. I did this backwards for me to be able to see it. Let me flip the beer around here. Try to do this gently. Or just flip it in such a way that I can see what I'm doing with the gauge. Okay, we'll refine this later. I can probably move a little bit closer. Okay, and then we put this on here. It's fighting with me a little bit. 1 second. Maybe I shouldn't need my hose longer. Okay, so get that on there. All right, yeah. Okay, next time I'll make the hose a little bit longer. This will work for now. And then basically with this, hopefully you can see this, but with this digital regulator, you just hit the power. Oh, I should talk about how this works. So these mini regulators, they have two parts to them, basically. This part on top here, you screw down to actually engage the shut-off valve on the canister. Nice thing about that is a lot of these mini regulators, if you screw in those little, those little 16 or 74 gram CO2 canisters, you instantly lose a little bit of gas as you're screwing it in because they don't have a separate kind of piercing thing. So that's kind of nice here. You can basically, want to make sure I've got my levels all the way turned off, and I do. I don't want gas going in right away. So basically, when you're ready to do something with your gas, you screw this down, and you'll hear it click. And then, so that with that all the way down, that is pushing down on the shut-off plunger on the top. Probably not using the right terminology, but on the canister. And then you hit the power button on the regulator, and then I'm going to very slowly turn it up until I see 1 PSI. I'm turning it the right direction. Yes. Okay. Keep going here. Wow. Okay. Okay, I hear gas now, so we're getting somewhere. Oh, too much. 2. Okay, we'll release. See where that stabilizes out to. That's 1.5. 1.1. Okay, we'll see if it sits there for a second. Just making sure even this gauge is kind of small, making sure it doesn't say 11. I don't think it went up that fast. Okay. Yeah, and I can, I don't really feel any massive amount of pressure. So that's staying at 1.1 to 1.2. So that should be good. The other thing is once I start cold crashing it, this may change a little bit. And this digital gauge does have a little watch type battery, and it'll shut itself off, and you just push the red button to see kind of what your pressure's at. So I will go ahead and stick that in the fridge to start cold crashing. And that's pretty much the process. And like I said, experiment. I don't know how it's going to go. This seems to be a reasonable approach. Again, if you're not too concerned about burning CO2 to do this sort of thing. But yeah, we'll see how it goes.